All right, this is the last one. And so now what we're going to do is find the area between the two curves. And so where is our center of mass if you have two functions that are creating it, not just one? And so it's the same exact thing. We're going to find our moments. So we're going to find our mi x sub I. And I like to call it m1 x1 because it's like our first one. But it really is our mi xi. And so it's the same idea. It's the mass, which is our row area. And the row is going to cancel just like before. So all we really have to do is look at ax. That's it. So what is our center here? Well, x is not changing, right? So I've already drawn my rectangle. And now we get a new point for our centroid of this rectangle, our center of mass. So we have x sub I. That right there is the same thing. That's our point. Now, if you plug x sub I into f, you get f of x sub I. And if you plug f of x sub I into g, you get g of x sub I. Well, the center would just be the average. It's the midpoint. So if you take your y coordinate and your y coordinate and you add them together and divide by 2, it tells you where the center is for the y. And now we do exactly the same thing we did before. So what is the area of this rectangle? Well, our height is f of x sub I. Take away g of x sub I. That would be the height. So if that was like 10 and that was a height of 4, it'd be 10 take away 4, which is 6. So it's f of x sub I minus g of x sub I. And the width hasn't changed. It's still delta x. So the area would just be length times width right there. So it's f of x sub I minus g of x sub I times delta x right there. And then again, we're just multiplying it by our x sub I. So there we go. And so the row is going to cancel. And so what we're getting here for our moment of x, just like before, is integral from a to b. But now it's f of x minus g of x dx, and we put the x in front, like that. Now, this is really, our f of x is the top function. Our g of x is the bottom. So it's really from start to finish of x, top minus bottom. So it's just like doing the normal area function that we would have here. Our area is the integral from a to b of f of x minus g of x dx, which is the integral from start to finish of top minus bottom. So it's the same thing as before, but now, so the only thing that's different with the moment for x is we just throw an x in front. And remember, at the very end, you got to divide the entire thing by the mass, because that's our main rule, and that's our area here. Right? The rows will cancel. Now let's move on to the y. So the y is going to be that y coordinate. So it's right here times the area. We already just found the area. It's this times this. So that one times delta x right there. And so we get our moment for x. See, I always do this too. It's moment y and moment x. Just put x and y if you want. You know, do whatever you want there. You just need a formula that matches. So we have integral from a to b. And then you notice we have f of x plus g of x and f of x minus g of x. So that would be f of x minus g of x times f of x plus g of x all over 2, right, dx. And so where does the square come from? Well, all you've done now is this is difference of squares. So it's f of x, g of x, f of x times f of x, g of x times g of x, and then the middle two cancel. Difference of squares. So that's the formula for y, and that's where it comes from. It's because our rectangle is changing. That's all that's happening. So that's why this x is the same, and it really is the same over here as well. It's just that our y coordinate has changed. All right, so let's try one. So again, the whole thing is based on this rectangle. You need to draw it now because we need to see which one is the top function, and that's the one we call f, and which one is the bottom function, and that's the one we call g, and then we can just plug them in. Okay, so let's graph this. So we have y equals radical x. That would look like that. And we have y equals x squared, which looks like that. So that's where they're going to intersect. So that is our area that we need. And so the top one would be square root of x. The bottom would be x squared. So when I draw my rectangle in here, I know that this is my top, which is my f of x, and this is my bottom, which is my g of x. Okay, so now we just need to see where it starts, and that's when you set them equal to each other. So square root of x equals x squared. And we know they're not coming back to connect to each other. So we already know it's just 2 points of intersection. So 0, obviously. And then the other number would be 1. If you made each one of them 1, it's going to work as well. So we're going from 0 to 1. So that would be my A. That would be my B. My f of x is rad x. And my g of x is x squared. So now let's first start by finding our area. So it's from 0 to 1 of f of x minus g of x. Let's actually write it. A to b, f of x minus g of x dx. Top minus bottom. Just like before. So 0 to 1, and then square root of x minus x squared dx, and we're going to plug that in the calculator and see what it gives us. And so it's 1/3. All right, now we just have to finish it. So my moment's already written right there, right? And so all it is between the moment for the y for our x is to divide it by a at the very end. So we're going to go for our x bar is 1 over a integral from a to b x f of x minus g of x dx. And again, I'd like you to understand where everything comes from. So again, for our center here, which is all of those rectangles that we're going to be using, so you can see there's all the different centroids for all the different rectangles. And when we add them all up, as we did in video number 2, all those points, and then divide them by the total mass, it gives us the actual centroid for the entire graph. So it's just x times the mass, and again, all you can think about it really is x times the area. And so our area is f of x minus g of x times delta x. So f of x minus g of x dx. So that's the area times the x coordinate. So now let's plug it all in. So we end up with 1 over a integral from 0 to 1 x rad x minus x squared dx. And we plug this in our calculator. And again, you can solve this all very easily analytically, but just to save time, we're going to plug it in the calculator. So that's what we have there. We hit enter, divide it by, grab that one, hit enter, and we get 0.4499. And now you can see the fraction didn't work, but this is really just 0.45. Now if you hit math fraction, it says it's 9/20. So our answer here is 9/20. So that's our x bar. And then we do it again now for our y bar. So this is integral from a to b, 1 over a, and then it's 1/2. And then now it's f of x squared minus g of x squared. Oops, backwards. Squared dx. And again, where does that come from? So again, it's the y coordinate times the area, which is this one times this one, which gave us this. And you could use that one as well if you wanted to. But that's our formula. All right, so now if we plug it in, we end up with 1 over a integral from 0 to 1, 1/2. And then our f of x is square root of x. So I'm just going to plug in, since I'm squaring it, I'm just going to put in x minus, and then that would be x to the 4th dx, just to save a little bit of time. And now we can plug this in our calculator as well. So our moment is 0.15 times the density, but we don't know what the density is, so it's just 0.15 here. And then we're going to divide by this one right here. Right there, 0.33, 1/3. So just to save a little bit of time, we're going to take that one, and we're going to times it by 3 because that's dividing by 1/3. Now math, fraction, enter, and you can see it's 9/20 just like the other. So what is our center of mass here? 9/20. And that makes complete sense because we have what a radical x and a square root of x, so we would expect it to be dead center there, right? So it's at 9/20, comma 9/20. That is our x bar, y bar, our center of mass. So if you have two functions, this is the formulas you're going to use. And again, it's all about the rectangle to find top and bottom. So even if you really don't understand where it comes from, I'd really like you to keep looking at it, playing with it until you do. But then right here is the rectangle. Top, bottom is what you really want to look at. Start, finish.